Theory of constraints is the third topic of this module. Theory of constraints, or TOC, is invented by Eliyahu Goldratt. He published this book, The Goal, in 1984, and it gained wide popularity for a few decades. TOC is an organizational change method that is focused on profit improvement. The essential concept of TOC is that every organization must have at least one constraint. A constraint is any factor that limits the organization from getting more of whatever it strives for, which is usually profit or efficiency. The goal focuses on constraints as bottleneck processes in a job shop, manufacturing, or any other service organization. However, many non-manufacturing constraints exist as well, such as market demand or a sales department's ability to translate market demand into orders. There are 5 steps to follow for TOC implementation. First, identify the system's constraints first. Rather than the strength, you want to look at the constraints. Second, decide how to exploit the system's constraints. Is there any method to lift up these constraints, or change it, or combine or merge them? Third, subordinate everything else to the above decisions to align with your decision. Fourth, elevate the system's constraints. Fifth, back to step one if you are done with elevating the system's constraints. These are the steps to follow. Look at this process. There are 3 workstations and it's flowing like this, and each workstation has a different productivity. If you look at carefully, you will see a bottleneck is formed here. A bottleneck is an activity in the process that determines the maximum output of a process. All processes contain a bottleneck. The process map example shown here details a 3-stage process where work center B can only produce 50 units per hour. Despite A and C being able to produce 200 units per hour, the whole process can only deliver 50 units per hour to the customer. If a company decides to improve activity A or C, it will have wasted its resources, as that improvement will make no difference to overall work rate. Only by improving activity B will an increase in overall work rate be achieved. Process maps are an excellent tool for highlighting bottlenecks and where to concentrate process improvement activity. In our example above, assuming the best that B can do is 50 units per hour, Lean would reduce the resources at A and C to 50 per hour, as this excess resource is waste. TOC would say that there are always variations in an activity. TOC predicts that if you balance resources so that each activity in a process chain takes the same time, then small variations at each work center compound, and the total output will be below 50 per hour. TOC suggests that you should do everything to maximize the output of the constraint. For example, ensure it doesn't run out of material and leave the other process with excess capacity, giving an output of 50 units per hour. Let's go over this question together. In the drum buffer rope methodology, what role does the drum play? And the answer is B, the process constraint. So the drum beat is the weakest point or constraints takt time, or I'm sorry, not takt time, cycle time. Therefore, it is constraining the whole process with that drum beat. So it's a process constraint. Let's look at this question. Goldratt's theory of constraints deals with money in relationship to 3 fundamental measurements for evaluating a system. Align the following measures with a monetary equivalent. A. Throughput is money going out. B, inventory is money stuck inside. C, operational expenses are incoming money. D, inventory is money going out. Um, so the answer is inventory is money stuck inside. You want to understand this because you have to sell the inventory and get it moving to make the business. Otherwise, it's just stuck inside of the organization. Throughput is not money going out. It is actually money making because you are, making the process efficient as much as you could. Look at this question. The theory of constraints concentrates mainly on A, understanding customers' needs, B, developing a value stream map, C, achieving on-time goal, D, removing process bottlenecks. The answer is D, removing process bottlenecks. It's about constraints and how to overcome them. Okay, in brief, if we summarize Module 4, improve phase, we have learned design of experiments, cycle time reduction, and theory of constraints. Design of experiments identify the vital views and their interaction effects and causal relationships, and we learned quantitative method how to do that. Cycle time reduction is crucial for many reasons, and we want to make a spaghetti-like process straightened and look like U or L, C, or straight line shape. Theory of constraints, as we have just reviewed, determines the drumbeat of the entire process, and we want to focus on these weaknesses and limitations first, and try to lift that limitations because that limit will determine the speed of the entire process. Okay, so this is the improvement phase. Thank you for your attention.